Well, this is Gonzalo from Techniker. Techniker is a research technological center located in the Basque Country in Spain. And well, during this presentation, I would like to talk about semantic interoperability and the importance it actually has in order to provide data sovereignty through the implementation of good quality distributed usage control technologies, and how we have already addressed these issues and how in a real use case. Well, I think that all of us know the importance that data spaces has in nowadays world in order to boost economic growth, the competitiveness, the innovation, etc. However, if we do not provide data sovereignty, data providers will be reluctant to share the data, and this issue will jeopardize the adoption of data spaces. Addressing the concept of data sovereignty, it has been defined as the self-determination of individuals and organizations with regard to the usage of the data. And in order to provide it in data spaces, which are actually distributed infrastructures, we do not have to only provide traditional access control, which actually controls if data is about to be released by a data provider, but we have also to provide control, to provide what is called obligations, that is, user restrictions in distributed infrastructures. And in order to do so, we have to implement distributed usage control technologies. However, the implementation of good quality distributed usage control technologies that actually provides data sovereignty, providing a good performance, is a big challenge. And in this presentation, I would like to pay attention in one of them, in one challenge, in which the semantic interoperability plays a key role. This is what is called the policy quality. The policy quality refers to the ability of a data provider to ensure that all the policies that have been implemented in a local infrastructure are consistent, so that they do not express contradictory rights that may lead to security breaches, that are minimal, so that there are no redundant policies that may take longer policy enforcement time, that are relevant, so that they actually control something that will happen in the use case, and that are complete, so that they actually control all the data sets that we have provided in our infrastructure. So the policy quality is a research field that has been very well addressed in access control through different policy analysis methods that analyze the large set of policies that have been implemented and detect some low quality policies. However, in distributed usage control, due to the novelties it presents, there is still a lot of challenges where the semantic interoperability plays a key role. The first challenge is related to the complexity of the policies. As maybe all of us know, in access control, policies are almost limited to permissions or provisions to perform an action by a subject or a resource. However, in distributed usage control, we introduce two main features. The first one is constraints. Constraints refine the applicability of those permissions and prohibitions over different circumstances that may range through time-based conditions, location-based conditions, and furthermore, these are highly expressive. We can express a time-based condition through a time interval or maybe through an event in the time. This complexity makes providing good quality policies much more complex. Furthermore, the second challenge is related, the second feature is related to duties. Duties are actual requirements that have been introduced in the model in order to execute some actions by the technology so that permission is granted, but we have to perform actions before and after data usage. Due to this added complexity that this model introduced, ensuring that the policy quality is much more complex, and also the policy analysis method must be able to identify all the different components of the policies that have been defined. The second challenge when it comes to provide the policy quality is referred to the policy implementation phase. Unlike access control, where only data providers implement policies on their datasets, in distributed usage control, data consumers can also implement policies on how he or she would like to use the data. In this regard, there is a policy negotiation phase that must be able to understand not only the policies that have been implemented by a model, by a data provider, but also by the data consumer. So one, I have already exposed the challenges related to ensuring that all the policies that we have implemented are with good quality. I would like to briefly explain and then show how we have already addressed on how these challenges in a real world use case. Well, just to comment, in the wind energy domain, the wind farm competitiveness is nearly connected with the maintenance of the wind turbine. Furthermore, the gearbox is one of the components that has a major impact on the performance of the wind turbine. Therefore, sharing not only the data that is monitored in the gearbox, but also sharing data that is calculated at the edge with all the stakeholders of the value chain is of utmost importance, for example, to allow component suppliers to improve their designs. In this regard, we have adopted the IDS ecosystem in order to promote sharing this data that is actually retained by wind farm operators and OEMs. And we have deployed 2 connectors in the data provider and the consumer side that enables implementing policies through a distributed usage control technology. So in order to ensure the policy quality in this use case, we have developed a policy analysis method that implements the IDSA usage policy language so that it allows us to analyze different policies that can be implemented following the IDSA usage policy language and expressed through JSON LDA, so that we can ensure at any time that all the policies that are actually implemented by a data provider are ensuring a good quality, so that there will be no security breaches and that the performance that will be performed afterwards at policy performance time will be okay. So going a bit into details, in this use case, we have developed an ontology for the wind farm domain, where we can express different policies, for example, for the data that is monitored at the sensor in a timestamp, in time-based interval. However, as I already said, constraints are highly expressive, so that we can also introduce another policy for everything the time. However, we have to know that in usage control, in order to grant data usage, both policies must be satisfied, so that this use case, this data will be unusable. Here comes the role of the policy analysis method. The policy analysis method will say to the data provider, to the policy administrator, okay, you have implemented those policies, but this data, if you negotiate with the data consumer, will never be usable because those policies will never be satisfied. In the same way, this issue is not only related to one resource, it's also related to dependent resources. This means, as I already said, we can define a policy in the data about the sensor for a timestamp. However, if the data provider has already said that the gearbox, all the data about the gearbox cannot be used, here comes a security breach, because somehow a data consumer can negotiate the data about the sensor and get this data. So once we have already ensured that the policy quality is provided at the data provider side, the other issue that arises in order to implement good quality distributed usage control technologies is related to how can we actually negotiate the policies so that the agreed policies, not only the offered, but not only the requested policies, but also the agreed policies are consistent, minimal, etc. In this regard, the main issue is that both sides can use different models in order to implement the policies, like the ODRL or the IDSA usage policy language. So here comes a big challenge where the policy negotiation phase must be able to understand both language, to have a mapping between those languages and make agreed policies consistent, minimal, relevant, and complete. I have to say that in our use case, we have used in both sides the IDSA usage policy language so that this challenge does not appear. And just in order to make some conclusions, I would like to point out that in nowadays usage control technologies, we are forgetting that making policies is not trivial. We have complex models, and it is of utmost importance to ensure that the policy quality, that the policies are of good quality, so that we do not say that we provide data sovereignty, but the data sovereignty is provided and through good performance, because if these technologies reduce its performance, the data flow will be affected.